Usain Bolt's world record 100 meters averaged 37.6 kilometers an hour, yet one 20-meter stretch of that same race averaged 44.7, and both numbers are exactly right. Berlin, a summer night in 2009. The gun. 9.5 seconds later, everything we thought a speed was falls apart. Across the whole race, he averaged 37.6 kilometers an hour, but one stretch of it, he was doing 44.7. So which one is his real speed? This is old, 2,500 years old. A Greek thinker named Zeno asked, at one single instant, is a flying arrow moving at all? Speed means distance divided by time, but in an instant, no time passes, so no distance is covered. Nothing divided by nothing. The measurement just breaks. It stayed broken until the 1600s, when Isaac Newton and Gottfried Leibniz tried something odd. Instead of measuring one instant, they measured a slice of time, and then made the slice smaller. Start from the ground. Put a gate here and a gate there, and time whatever runs between them. 100 meters in 9.58 seconds. That is 10.5 meters every second. Now cut that same race into 5 20-meter pieces and time each one. Slow, fast, faster, fastest. Easing. The one true speed falls apart into a shape. Here is where the 44 came from. Between the 60 and 80-meter marks, he took 1.61 seconds. 20 divided by that is 12.4 meters a second, 44.7 kilometers an hour. But 20 meters is still a chunk of race, so don't stop. Before I show you, what do you think happens to the number if we keep cutting the slice smaller? The whole race, divided in one go, gives 37.6. One 20-meter slice gives 44.7. Shrink the slice further and the answers stop wandering. They settle. That settled number is the speed at one instant. So that is how one race holds two true numbers. Nobody told you which slice they used. In Berlin, they actually did it. A laser measured Bolt 100 times every second. His fastest instant, about 44 kilometers an hour, came just past halfway, 5.24 seconds in. And here is the strange part. Over the last 20 meters, Bolt was slowing down. Nobody finishes 100 meters strong. The winner is whoever slows down least. Now the upgrade. A bare number tells you how fast, but not which way. So physics turns the number into an arrow. Its length is the speed, its heading is the direction. That arrow is called velocity. Watch the arrow. It can get longer, it can get shorter, or it can swing to a new heading. Any one of those is a change. And acceleration is simply the name for the arrow changing. 4 days later, Bolt ran the 200 and averaged almost exactly the same speed as his 100. But half of it is a bend. Watch him through it. The arrow keeps its length and swings the whole way round. The inside lane of a track curves with a radius of 36.5 meters. Speed squared over that radius gives 3 meters per second squared, about a third of gravity, pulling him sideways the entire bend. You have both of these in your car right now. The needle is a shrunk slice, near enough this instant. Your phone divides a whole second of travel. That is why they never quite agree. Anti-lock brakes compare each wheel's speed this millisecond and let go before it skids. The chip in your phone feels nothing but the arrow changing. A spacecraft rounding a planet barely changes speed and is accelerating hard the whole way. 3 lines and you can read any moving thing on Earth. From here on, physics only ever watches one thing: the arrow. Forces, gravity, orbits, collisions, every one of them is an answer to the same quiet question. What makes the arrow change? Thank you for watching. Our small team works tremendously hard on every one of these animations. Following, subscribing and sharing is what keeps Ortus alive. There is a new video every day. See you tomorrow.